Look up on a clear night, and you'll see the same glowing sphere that has orbited our planet for over 4 billion years. For millennia, we used its phases to build our first calendars and used these lenses to chart its craters. But what would happen if that fixture of our night sky simply disappeared tonight? Because the moon is so ever-present, it's easy to overlook how much of our world's basic physics relies on its constant presence. Suddenly, it is gone. The night sky immediately plunges into a level of darkness modern humanity rarely experiences. Across the wild, millions of nocturnal animals stall in confusion. Moths lose their way, sea turtles halt on beaches, and migrating birds lose their compass. In observatories around the globe, astronomers stare at empty coordinates, trying to process the physical impossibility of a massive planetary body vanishing into the void. The loss of light is only the surface of the crisis. Earth has lost its primary gravitational anchor, and a countdown to planetary unraveling has begun. The first physical casualty of a moonless Earth is the movement of our oceans. As shown here, lunar gravity pulls on our oceans, creating the daily high and low tides that sweep across the planet. Remove that gravity, and those massive oceanic bulges collapse. We are left only with the much weaker gravitational pull of the distant sun. Within weeks, the rhythmic energy of our coastlines drops. High and low tides shrink to a fraction of their size, leaving shoreline water stagnant. Coastal animals that rely on the surge of new water to bring food and clear waste find their environments transformed into still, oxygen-depleted pools. Without that gravitational heartbeat, the coastal food chain begins to fracture. Looking ahead thousands of years, the loss of the moon threatens the very stability of our climate. Currently, Earth spins at a steady 23.5-degree angle. The moon acts as a counterweight, preventing the planet from tipping over as it orbits the sun. Without that weight, Earth begins to wobble. Over millennia, the planet tilts back and forth at extreme, unstable angles. This erratic tilt would shatter global climate patterns. The steady progression of spring, summer, and fall would become a thing of the past. A sudden shift in the axis could plunge the tropics into a permanent ice age, while historically cold regions are forced to endure direct, scorching heat. The moon is the silent partner that keeps our atmosphere predictable and our world inhabitable. To understand why we are here at all, we have to look back at the beginning of the Earth-Moon partnership. In the early solar system, Earth spun rapidly, with days lasting only 6 hours. The moon's gravity acted as a physical brake, gradually slowing that rotation down. This deceleration stretched our days into a stable 24-hour cycle, allowing surface temperatures to stay within a range that life could tolerate. Biological life evolved to sync its internal clocks with this exact rhythm. When we see an astronaut standing on the lunar surface, we are seeing the result of 4 billion years of planetary stability. Our existence is the result of this ancient gravitational bond. But tonight, that bond remains. The moon is right where it has always been. The tides continue their steady movement, and the Earth's axis remains locked in its comfortable tilt. Families and stargazers can look up with a new understanding of our silent companion. The moon is the guardian of Earth's stability, a partner we only truly appreciate when we imagine the chaos of its absence.